Hi, I'm Julianne Berry-Stoltz, a product management intern at MTS, and today we will be going over tensile testing basics on a landmark system. A tensile test is one of the most popular tests for determining materials' mechanical properties. This test subjects a sample to a force along one axis until failure, which is when the sample breaks. Tensile tests are used to acquire data such as ultimate tensile strength, yield strength, elongation, and elastic modulus. These material properties can be used to characterize materials and to determine if they're suited for a given application. Test samples can be many different materials, including composites, polymers, ceramics, or metals. Different grips must be used depending on the shape of the sample to ensure the sample ends are held firmly during testing. The testing machine has several parts: a servohydraulic load frame, a load cell, an alignment fixture, grips, and an extensometer. We will be using an MTS Landmark 370-10 load frame, which can generate up to 100 kilonewtons or 22,000 pounds of force. Attached to the frame is an MTS 100 kilonewton load cell. This device is used to measure the force transmitted to the specimen. It is attached to an MTS 609 alignment fixture. Grips are attached to the load cell and the actuator, which is in the base of the Landmark frame for this configuration. We will be running a tensile test on a rounded, low-carbon steel sample using the MTS Model 646 hydraulic collet grips. These grips are easy to use with an integrated grip supply within the load frame. The sample is placed in the lower grip, which is closed by turning the grip control to the right. Then the lower grip is raised by using the jog buttons on the top of the screen. Once the top grip is aligned with the top of the sample, that grip is closed by turning the second grip control. Here, it is important to not raise the lower grip too much, as this will crush the sample, leading to inaccurate test results. A good tip would be to mark the insertion depth ahead of time. The hydraulic collet grips help ensure proper alignment and help minimize the preload on the specimen. After the specimen is placed in the grip, an MTS 634 extensometer will be attached directly onto the specimen by closing the quick attach clips around the sample. An extensometer is a device that is used to accurately measure the elongation of the sample, down to a micrometer scale. Using the extensometer is much more accurate than using the change in actuator displacement that includes the elongation of all of the equipment between the crosshead and the base of the frame. When using an extensometer, it is important to check if it can be used through fracture, since a large displacement of fracture can permanently damage some extensometers that are not designed to handle it. Now that the test is set up, we will set up the software using MTS Test Suite TW. We will be using the pre-made template, MTS Servohydraulic Tension with an extensometer. Each of these boxes represents a command, using parallel paths for break detection and data acquisition. Before we can begin testing, we will go to the monitor page and ensure that our inputs are accurate. The extensometer gauge length is 20 millimeters, and the diameter of the specimen is 1/4 inch. We will set the test rate to 0.05 millimeters per second. This test will begin once we click the green play button. The actuator will start to move, and data collection will begin. This test is now running in actuator displacement control mode. The resulting load and extension graph can also be changed to a load strain graph by right-clicking on the graph and choosing the strain option. Once testing is complete, we can remove the specimen and the extensometer from the test space and return the load frame to its zero position. Now you know the basics of a tensile test on a landmark system. Thanks for watching.